The following video was taken from Ace Organic Chem Elite, full of movies, videos, flashcards, a test bank, and much, much more. Plans start at less than $20. Sign up today and get 2 free ebooks with your subscription. Cancel anytime, money back guarantee if not completely satisfied, and you keep the ebooks. Just click on the link in the video notes. And now, on to our video. In this video, we're going to talk about the reactions that Grignards can undergo. So in the previous video, we looked at Grignard reagents and some of their properties and some of the things that they can do. Now we're going to look at the reactions that they undergo. So remember, we talked about synthons before. And for a Grignard reagent, the synthon, or for retrosynthesis purposes, what it looks like is that. Remember, it's a negative charge on whatever it's attached to. So if our Grignard was methyl magnesium bromide, the synthon, or the pretend thing it would be CH3 negative. So that's what you need to think about when we're doing these problems, that these reagents are great nucleophiles. And put that up here and let's look at some reactions. So the first reaction we're going to look at is making alcohols with Grignard reagents. And I'm going to use the same Grignard each and every time, and it's going to be methyl magnesium bromide. So if we took a ketone, and we subjected that ketone to methyl magnesium bromide, the reaction would be relatively simple. The ketone is our electrophile, methyl magnesium bromide is our nucleophile. We attack, kick up those electrons, and on aqueous workup, I'm going to draw this a very specific way. On aqueous workup, we form the alcohol and we add a methyl group to it. This isn't the greatest geometry in the world, but hopefully you see what I did. All we did was add a methyl group and turn the ketone into an alcohol. And better yet, it's a tertiary alcohol. That's kind of cool. You can do that. You can make tertiary alcohols from Grignards and ketones. Let's go somewhat in the same direction. What if we didn't use a ketone, but it was an aldehyde? What would happen? Well, remember, same thing. Aldehydes are also electrophiles. It would be attacked at the base, but we wouldn't form a tertiary alcohol. We'd form a secondary alcohol. So let's write that out there. We got a tertiary alcohol from a ketone. We got a secondary alcohol from an aldehyde. Anybody think of a way to get that primary alcohol out? I think you guys can do this. It's pretty simple. What if we used formaldehyde? Ta-da! There it is. So really, what we've done is, this is ethanol. It's a little harder to see, but this is ethanol. So let me draw this out in a different way. There we are. Same thing. This is ethanol. CH3 is from our Grignard. The CH2OH used to be formaldehyde. And what we got out now is a primary alcohol. And this is kind of cool because now you guys know a way that we can take a Grignard and add CH2OH to the end. So let's look at a place that might be really useful. What if you had that? Let's just start with that. We know that with bromine and light and heat, under free radical conditions, we can turn that into the bromide. Now we can turn that into the Grignard. I shouldn't be blowing anybody's mind with this, but you can hopefully see where I'm going with this. Now, what if I subjected that Grignard reagent to formaldehyde? If I subjected that Grignard reagent to, here, I'll do this. I'm going to cheat. I'm just going to bring that over there and shrink it. If we were to subject that to formaldehyde, we would take this, and this would now become CH2OH. And in 3 steps, what I've done is I've started with cyclohexane. Free radical halogenation puts a bromine on there, something for it to react with, a molecular handle. Turn it to the Grignard, react it with formaldehyde, and in 3 steps, I've gone from cyclohexane to a cyclohexyl alcohol. Not too shabby. All right, so 2 more reactions with alcohols, and then we're going to move on here. So we've talked about, let me just do some copying here. I guess it's up here now. All right. There we are. That was a little messy. I apologize, but we've got it now. What if it wasn't an aldehyde? What if it was an ester? Well, this is going to give us a bit different. Oh, here, we need to do this. Make it a legitimate ester. What's going to happen now is esters are what we call ejectable groups. So the first thing that happens is you eject off that ester. Then the second thing that happens is you add methyl magnesium bromide again. What you get out of it is double addition of the Grignard. So our Grignard added twice. Still a tertiary alcohol. It's still a tertiary alcohol, but now, instead of having R group and one methyl group, we have R group and 2 methyl groups. So you can add your nucleophile twice when it's to an ester. One last example with alcohols before we move on. This is a little bit more complicated. And at least in our videos, we haven't started talking about this yet, but there's no better time than the present, I suppose. If you had an alpha-beta unsaturated ketone, remember, you have 2 places you can add here. You can add at the base of the carbonyl, or you can add at the end of the double bond. If you add at the base of the carbonyl, it's called 1,2 addition or direct addition. And if you add at the end of the double bond, at the end of the unsaturation, it's called 1,4 addition or Michael addition. Nucleophiles can and will attack it one or the other depending on what the nucleophile is. Okay, so if you have this and you have a Grignard reagent, we're going to stick with the one we've been using. The question now is, you have 2 electrophilic sites, 2 potential electrophiles, only 1 nucleophile. Which is going to add to which is the nucleophile going to add to, and I'll tell you the answer. It's going to add 1, 2. Grignards add 1, 2 to alpha beta unsaturated ketones for reasons that some people want to know. I don't think it's important to this course, so I'm not going to get into it here. But suffice it to say that that's what you get out. You get out the direct addition, the 1, 2 addition, and you get out, it's still a tertiary alcohol. You get out this tertiary alcohol, not the one that adds 1, 4. So that's what we've got with forming alcohols. Now I'm going to show you a couple ways to form ketones with Grignard reagents. So let's say you had butanitrile. And I'm going to stick with the Grignard we have. Remember, that carbon of the nitrile is electrophilic. This carbon's nucleophilic. So again, we're going to form a carbon-carbon bond, which is awesome when you can do it. Electrons are going to add up on the nitrogen, end up on the nitrogen there. At first, what you get out and there is the methyl group we added. You get out the imine. But when you work it up under acidic workup, you hydrolyze that imine. What you get out is the ketone. So here it is. We took, and let's count our carbons to make sure we did this right. 1, 2, 3, 4, 5 carbons. We added 1, so we should have 6 in our final product. 1, 2, 3, 4, 5, 6. Yep, so we did it right. This is a pretty nifty way. Can't believe I just said that. It is a pretty good way to turn a nitrile into a ketone. That's a great little reaction right there. And we added the CH3 there, and we determined what ends up on the other end of that ketone. So that's one way to form a ketone. The other way is using kind of a crazy amide. And I'm going to draw that amide out. This is a goofy one, right? And the R can be just about anything. But you can take this amide. We can subject it to methyl magnesium bromide. And that magnesium bromide is only going to add once. It's going to come in. We're going to kick off that nitrogen because it's really stabilized. It's a good looking little thing. And what we get out there's our methyl group that added to it. Again, we get out a ketone. Not too shabby. So here's 2 ways to get a ketone out. We saw a bunch of ways to get alcohols out. I want to show you 2 last reactions that you can do with Grignard reagents, which again are pretty awesome. These are a couple of my favorite. Well, I guess one reaction and one reaction you cannot do. So let's take, we're going to use a different reagent this time. So we're going to use propyl magnesium chloride. We're going to subject that to carbon dioxide. And remember that carbon dioxide looks like that. So that carbon in the middle of carbon dioxide is crazy, crazy, crazy electrophilic. And there's our nucleophile at the base of magnesium chloride. So it's going to come in and attack, kick the electrons to the oxygen, and what you're going to get out after acidic workup so I'll say then after acidic workup is you got out a carboxylic acid. This is awesome. Count our carbons to make sure we did it. 1, 2, 3 in the starting material, and we added 1 from the carbon dioxide. 1, 2, 3, and the 1 we added from carbon dioxide. We can draw it out even. I like this better when it's even drawn out, because I think it shows where everything came from. There's your 2 oxygens from the CO2 right there. We just bent it right around, formed from magnesium chloride there. We formed a carboxylic acid. That's a great reaction right there. You can use that to your benefit. And further, I mean, let's look at this. What if you just started with any alkane? We're going to do first, we're going to do bromine with light and heat under free radical conditions. Shorten this up because we're going to need a little bit of room here. And why don't we even put the right bromine in there? There we are, much better. So that, remember, forms our bromide from nothing, from just a plain old alkane. We get a bromide out. We're going to turn that, and here I'm going to be a little slick about this. Ready? First we're going to turn it into the Grignard. And then in the same pot, without even doing anything, I'm going to add CO2. Then your professors are going to, many professors would want you to know this. 3, in the final step, you need to do this. An acidic workup. So I'm tidy it up here a touch. Magnesium turns it to the Grignard, CO2 turns it to the carboxylic acid, just like we did up here. And then aqueous workup gives us carboxylic acid. So we went from just a plain alkane to a carboxylic acid. Do you call it 3 steps? I call it 3 steps because I don't count that aqueous wash as a 4th step. 3 steps. From alkane to carboxylic acid. Really nice. Last reaction I want to show you. Let's take (3-pentyl bromide, or 3-bromopentane, whichever way you want to look at it. What if I try doing a Grignard coupling on this? Okay, so let's, what if we had this? Try that again. Let's look at this for a second. Starting material. It's easy to see that, remember that alkyl halides can act as electrophiles. And we know that just like with alkyl ones, aryl magnesium chloride, right? This phenyl magnesium chloride is what this is called. That carbon is nucleophilic. So I have an electrophile and I have a nucleophile. You would think these react, but it doesn't. this doesn't work. And it gives you a crazy mixture and a bad reaction. And the reason this is because that magnesium can actually go between the two here. And it's not just a straight displacement, unfortunately. There's other organometallics that will do this, but I'm going to put this in. I'm going to actually write it down. Grignard reagents will not react with alkyl halides. It just doesn't work. You can't do this substitution on here because, again, this magnesium, it's not really a full bond. And the magnesium can come back over here, and it can go into the bromide there. And you never really get a reaction. So remember that you don't want to do this. You can't do a Grignard and an alkyl halide. So hopefully that was helpful. We're going to continue our series on organometallics next with alkyl lithiums.